Imagine waking up one morning and realizing the entire internet has just been unlocked. Your bank account, your emails, every encrypted message you've ever sent, wide open. It sounds impossible, but scientists have a name for the day this could happen. Q-Day. The day quantum computers become powerful enough to break the encryption that keeps our digital world together. Today, we're asking, can quantum kill the internet? And if so, what can we do about it? Every second, trillions of bits of information move across the web, safely thanks to something called public key cryptography. It's the digital equivalent of a lock and key. When you log into your bank, your browser uses math, massive prime numbers, complex equations, to keep your data hidden from anyone trying to peek. Algorithms like RSA or elliptic curve cryptography are based on problems so hard that even the world's fastest supercomputers would take thousands of years to solve. But for quantum computers, those problems aren't so hard anymore. A normal computer works with bits, zeros and ones. A quantum computer works with qubits, tiny particles that can be 0 and 1 at the same time. This strange property, called superposition, lets a quantum computer explore countless possibilities simultaneously. And when qubits become entangled, changing one can instantly influence another, no matter how far apart they are. These aren't science fiction ideas anymore. They're real and incredibly powerful. In the 1990s, mathematician Peter Shor proved that if you can build a big enough quantum computer, it could factor huge numbers exponentially faster than classical ones. In simple terms, it could break the locks that secure our digital world. Right now, your messages, your credit card info, even your country's classified data are protected by those same unbreakable mathematical locks. If someone builds a large-scale quantum computer, those locks could vanish overnight. Experts call this moment Q-Day. No one knows exactly when it will arrive, but governments and companies are already harvesting encrypted data now, saving it to decrypt later once quantum is ready. Harvest now, decrypt later. It's not paranoia, it's official policy for some intelligence agencies. As Wired warned earlier this year, the quantum apocalypse is coming. Be very afraid, because when Q-Day comes, it won't just break passwords, it could break trust itself. So, how close are we? Companies like Google, IBM, and China's national labs are locked in a global race to reach what they call quantum supremacy, a point where quantum machines outperform every classical computer on Earth. Google's newest chip, Willow, has about 100 qubits. Impressive, but still far from the millions needed to break encryption. Still, progress is accelerating. Some analysts predict it could take 30 years. Others say 10. No one knows for sure. What's clear is that the time to prepare is now. Just this year, Europol warned banks across Europe to start quantum-proofing their systems. The UK's Cybersecurity agency set a target: transition to quantum-safe encryption by 2035. And yet, a 2025 study found that less than 5% of organizations have even started preparing. Thankfully, scientists aren't standing still. There's an entire movement working on post-quantum cryptography, new algorithms that even quantum computers can't easily break. After 8 years of research, the US National Institute of Standards and Technology, NIST, selected its first set of quantum-resistant encryption standards in 2024. They're based on exotic math, lattices, error codes, and hash trees. But the goal is simple: rebuild the web's foundation before it collapses. Other teams are testing quantum key distribution, using the physics of photons to share encryption keys. If anyone tries to eavesdrop, the system instantly detects it. It's already being tested in networks across China, the US, and Europe. The future might even combine both classical cryptography and quantum communication to create a hybrid internet that's safer than ever. Transitioning the entire internet won't be easy. It means replacing every lock, every key, every protocol in banks, satellites, hospitals, and phones. Moody's analysts recently called it one of the most expensive migrations in cybersecurity history. But doing nothing could be far worse, because when quantum computers finally arrive, they won't just unlock data moving across the internet. They could reveal everything we thought was secure, going back decades. That's why some experts say the real countdown isn't to when quantum computers arrive, it's to when we stop preparing. So, will quantum kill the internet? Probably not, if we're ready. The same technology that threatens our digital world could also make it stronger, faster, and safer than before. The question isn't whether quantum will change the internet, it's whether we'll be smart enough to change first. This is the next great encryption revolution, and it's already begun. Thanks for watching. If you found this helpful, subscribe and stay curious.